Hello and welcome back to another episode of Math with Sohn. Today we are going to be dealing with forces on an inclined plane, okay, and how and when they would be accelerating and why they would be accelerating and so on and so forth. To do this, we need to first draw a free body diagram, okay, so on this inclined plane right here, on this inclined plane, we have the block, and you got your force natural, the natural force moving it up that way, always perpendicular to the actual plane. And then you have the force of gravity. This part, which would be mg cosine of theta. And this part would be mg sine of theta. For those of you that have missed the previous video, I would recommend looking at that based off of the angle right here. Now, if we redrew it right here, that would be like so, essentially. So that's what we're doing here. We need to find the parallel component because this parallel component would indicate how quickly it is traveling down said ramp. Okay, notice how I said how quickly it's traveling down the ramp. We're not looking for the force yet. We could find the force if you wanted to, but we're looking for how fast it is moving down this ramp. Well, that would be the mg sine theta component. So we are going to deal with that. Now, this is the force, and if force is equal to mass times acceleration, what would be the acceleration part then? Just the g sine theta. Okay, so we're only looking for the acceleration. If we want the force, we can throw in the 5 kilograms. It doesn't matter how much something weighs. Whenever you drop two things in a vacuum or with frictionless surface, doesn't matter how much they weigh, they're going to accelerate the same way. So that 5 kilograms for the acceleration doesn't matter. We need to do g times sine of theta. Well, g is 10 approximately meters per second squared. You can also use 9.1. That's your g. Times sine of theta. Well, sine of theta in this case would be 15. So if we did that, we would get approximately 2.5 meters per second squared for how quickly this object is shooting down the ramp. Okay? Which is slightly less than what gravity would have done because it's moving it down, it's spreading it out slower a little bit over this 15. It's not falling straight down. It hit the, well, it supposedly, if you think of it, it kind of hit the ramp and then started sliding down, which would be a lot slower of an acceleration compared to just going straight down, I would imagine. All right, next one. We got, suppose that you now want to drag a 5 kilogram mass up and down a frictionless 15 degrees inclined plane. How much upward force would be needed to accelerate the 5 kilograms up the incline at 3 meters per second? All right, so let's start with the idea of what would be the acceleration of it and what would we have to be counteracting. So I'm going to go back to this example because it's the same exact thing. It's 5 kilograms, 15 degrees. So let's say that we have this 5 kilograms and it's going down. What would be the force of that block as it's moving down? Well, the force of that block would be mass times acceleration. And we just found its mass. Excuse me, not its mass, its acceleration. So if its mass is 5 kilograms, 5 times the approximate 2.5 gives you 12.5. However, I've done it a little more precise here. 5 times 10 times sine of 15 gives us exactly 12.94. And that would be 5 times sine of 15 times the 10. And this is going to be, in reality, 12.94 newtons. Going back to our original problem. We have 12.94 newtons. That would be to just fight gravity, and that would be to neutralize gravity. How much more are we going to have to do to be able to neutralize and get it to up to 3 meters per second squared? So we got gravity right here. We beat gravity if you apply 12.94. Then how much more do you need to be able to get it up to 3 meters per second squared? Well, if that's the case, you would need an additional mass times acceleration, and you're applying it upward. So it's an upward force. If it's an upward force, then it's going to all be directed directly towards the upward part. And you can do 5 times 3 to get 15 newtons for that portion. And if we do 5 times 3, mass times acceleration, that we would have to combine this 15 and this 12.94. And when we combine those, we get 27.9 newtons as a combined force to get that all the way up and accelerating to 3 meters per second squared. You would have to hit it really hard, so to speak, to get that to happen. All right, that's going to do it for this one. Until next time, everybody, I will see y'all later. Stay positive, my friends. Bye.